Hi, in this video I want to discuss the distribute on curve part of the MultiCloner. For this I'm going to create a new MultiCloner object because I want to do something other than the distribution that I have here, and I'm going to create a new forester tree. So let's change the forester tree from the tree library to an aspen tree. So we clearly have a different tree here. And I'm gonna reduce the amount of branch levels for level 1 so that we have a more optimized display. Alright, so I'm gonna take the aspen tree and parent it under the new MultiCloner, and I need to specify, even though I'm gonna use the distribute on curve, I need to specify the distribution geometry. So I'm gonna take the landscape and bring it down here. So by default I'm gonna get this, which is the regular behavior that I get. First of all, I'm gonna reduce the clone size and I'm gonna increase the verticalized value so that the trees are vertical. But as I said, I want to use the distribute on curve, so I need a curve. I'll go to my top view and I'll just draw a curve that just goes like this, and from the front view I'll raise it up and I'll just move this tree out of the way. So this is what I have. I have the curve above the distribution geometry. I'm going to turn off the first MultiCloner because I have no more need for it, and I need to use the distribute on curve for the new one. Okay, so how do I use it? It's very simple. First I check distribute on curve. Nothing happened yet because I have no curves present in the path curve list. So all I have to do is just bring in this curve, and right away I see that I have some new trees being generated. So I want to see the trees generated from the curve and not from the regular distribution. So I'll go to distribute on geometry and set the clone count to 0. And this is what I have now. The first thing I'm going to do is change the curve spacing. If I wanted to have less trees, I would increase the spacing between them, and therefore I'm going to have less trees. If I want to have more trees, I would decrease the spacing. Now this space here is coming from the fact that the curve is not closed, so I can select the curve and just close it like this. If you look closely, you'd see that the trees are actually planted exactly on the distribution geometry, which is really what I want, although the curve is above the geometry. And this is happening because we have the project on distribution geometry checked by default. If I uncheck that, then the objects will be distributed exactly on the curve. So just selecting points from that curve will actually change the position of the distributed geometry. But project on distribution geometry will actually give you the proper projection regardless of the shape of the curve going up and down. What matters is the actual horizontal shape of the curve. So selecting any point now will give you a real-time feedback. Of course, if you go beyond the projection limits, then the other trees will actually go to the distribution curve. Alright, so that's the curve spacing that we have here. The curve offset, if I uncheck snap to distribution geometry, let's move this back down. The curve offset has 3 values. It can be offset in X, Y, or Z. So here I'm offsetting in X. Now you should note that the curve direction is pointing downwards by default because I created that in the top view, and this is how the x-axis is going. So if I set this to 0 and I increase back that axis, I'm gonna get this type of change. If I increase the y-axis, I'm gonna get this. So the y is not pointing upwards again because of the orientation of the curve, and the z-axis is taking the place of the y-axis. That's the vertical one. So in this case the clones are going up and down. So that's the curve offset. Really in this case what I would use this for is to change the rigidity of the curve, and therefore I would create some thickness to the distribution. For example, 500 by 500. So now I have a thickness. I can reduce this That's the thickness that I was talking about. Let's increase this a bit more. Let's say 1000 by 1000. And make sure that this is larger. All right, so I'm going to have more. And now, whenever I project these onto my distribution geometry, I'm going to get this result. So this was used to actually add to the thickness of the curve instead of being exactly on the curve like this. Okay, so that's the curve offset and what I would use it for. The next thing I want to discuss is the curve up vector x, y, z. We discussed this before when we talked about the up vector from here. It's the same concept. This will actually change slightly the orientation of the clones over the distributed geometry. Inherit curve rotation, in case I do check this, then the clones will take the orientation of the curve. So the orientation of the curve is not normal now because of the way that Cinema 4D orients the center whenever you create the curve in the top view. So in case you wanted to do that, you would get something like this. And in this case, no, I don't want to do that, but you can also change the up vector to get some weird results in case you wanted to do that again. The normalized curve will actually create even spacing between the curve points or the trees, generated trees here. So if I increase the curve spacing from here, I have an even distribution along the curve. If I uncheck this, then my distribution is not even. So normalized curve will give you an even distribution, and it depends on the iterations value. So in case you had a lot of detail in the curve, then you would have to increase this iterations value to actually get a faithful distribution on the curve. The last topic I want to discuss is the clone on spline points. And this is important because sometimes I need to place trees at exact locations. For this, I'm going to create a linear curve. And here, let's say that these are the locations that I want to place the trees on or the clones on. If I wanted to do that, all I have to do is, first of all, I'm going to remove that curve, the one I had before, and use the new one. So now the new curve is placing the trees. But if I choose clone on spline points, then I'm just going to get trees exactly on the points. And this is very useful because now you can actually grab the curve points and move them, and therefore put precise locations for the trees on the distribution geometry. And because I have project to distribution geometry on, it doesn't really matter if I move up and down because the tree will be planted exactly on the ground. So again, use this function whenever you want to place trees on exact locations on the distribution geometry. If you add points, of course, you can just use that to add more trees or more clones to your distribution. So I'm just pressing Control and just adding trees wherever I want. You can have more than one curve. So for example, if I just create a circle, I can drag the circle down over here. I'm going to rotate the circle 90 degrees. If I just look at the circle, it's not really giving me the proper orientation or the proper location. So to solve this problem, I can change the plane of the circle, in this case to XZ, and now I have the proper projection like so. Remember that here I'm using the clone on spline points. If I remove that, I would get the circular distribution of the trees. So these are the different options that we have in the distribute on curve, which is very powerful and very useful inside the MultiCloner object.